Factorial ANOVA, including two-way ANOVA, three-way ANOVA, followed by post hoc test in SPSS. Two-way ANOVA followed by post hoc test in SPSS. Two-way ANOVA is factorial ANOVA. Here in this SPSS, we have data that have three variables. The first two variables, which are independent variable, the job and the gender. So here we have the first factor, which is the job, the second factor, which is the gender, and the third variable is the salary variable, which is continuous, and this salary is the dependent variable, and it's measured in pounds, and it is the salary earned annually by individuals or each individual. For the factor job, there are four different levels or groups or categories: doctor, dentist, pharmacist, nurses. For the gender, there are two categories: male and females. So we have here two factors with sub-levels. This is an example of 4x2 analysis, as we have 4 levels and for the job and 2 levels for the gender. To find out whether there is a differences in the salary earned by each group in the factor 1, doctor, pharmacist, dentist, and nurses, and whether the sex or the gender of an individual also have an effect on the salary, whether a male have more salary than a female. And since we have here two factors, the way to do statistical analysis is to perform two-way ANOVA statistical test, as we have here two factors. To do the test, 3 null hypotheses will be generated. The first null hypothesis states that there is no differences in means between groups for factor 1. The second hypothesis states that there is no differences in the mean for factor 2, males and females. And the third null hypothesis, there is no interaction between factor 1 and factor 2. To perform two-way ANOVA, click on Analyze, scroll down to General Linear Model and select Univariate. In this new window, drag the job into the fixed factor, the gender into the fixed factor, as we have here the two factors, and the salary, which is the dependent variable, into the dependent variable area. Click on plots, and for the profile plot, select job, drag it into the horizontal axis, add it to the plot here. Select the gender, drag it into the horizontal axis, click on add, and then select again the job into the horizontal axis, the gender into the separate lines, and click on add. Click on continue. Click on post hoc test. For post hoc test, since gender is just two categories, we're going to select the jobs as it have 4 levels in it. And we're going to stick with Tucky here. Click on continue, and for the EM estimated marginal means, click and select all and drag it into the display means for the overall jobs, gender, and the interaction. And for compare main effect, select the LSD, click on continue, click on save, and then tick the unstandardized. Click on continue, and for options, click on descriptive statistics homogeneity test for ANOVA assumptions and estimates of effect size. Click on continue, and if you click on OK, several tables are generated with plots towards the end. So in the first table, which shows the descriptive data for the job, which have 4 levels: doctor, dentist, pharmacist, and nurses, and there are 24 individuals in each group. And for the gender, when the data split by gender, have male or female, both are 48. The second table is a descriptive statistics that shows the means and the standard deviation for each factor in combination with the second factor. For doctors whom are males, that's the mean for the salary or the average they earn, and for doctors whom are females, this is the salary, the average salary they earn. So this is the description of the data for both factors. The third table is the test for homogeneity of variance using Levin's test. It shows that there is no homogeneity of variance. The data has violated one of the assumptions for two-way ANOVA, which is homogeneity of variance. As here shown from the table, there is heterogeneity in the variance. However, the ANOVA is a robust test, and we will keep this in mind, but we will continue with the analysis. The next table is the table for test of between subject effect. This table will determine whether the null hypothesis can be accepted or rejected based on the significant level p-value. If the p-value is less than 0.05, then we reject the null hypothesis. The two factors, the factor for the job, the factor for the gender, and then the interaction between the two factors. So for the first factor, the effect of job on the salary, or whether the salary is affected by whether you are a doctor or a dentist or a pharmacist or a nurse, it shows that there is a significant differences. So jobs category have an influence on the salary, and as we seen here, that doctors having higher salaries compared to dentists and pharmacists and nurses. So there is a significant differences in terms of salary based on the profession. So this factor, in this factor, there is a difference in the salary. For the gender, whether you are a male or a female, whether your salary is affected by your gender, the p-value is less than 0.05. So there is a significant difference between male and females. And for the interaction, whether jobs and genders can have an influence on the salary, again, there is a significant difference. So all the null hypotheses will be rejected, and the analysis here showed that there is a significant difference between levels within job category or job factor, and differences between gender for the gender factor, and also interaction between the two factors. The next or the following tables look at the grand mean, the estimate. What is important also to consider in this analysis is the pairwise comparison, since we found out that there are differences between all 4 professions in terms of salaries. Then the Tuckey test will compare groups together and to make all possible combination to find which one is significant and which one is not. Here in this pairwise comparison, doctors compared to dentists, there is a significant differences in the salary. When the doctor also compared to pharmacists or to the nurses, again there is a significant differences. So this pairwise comparison will pinpoint the groups or two groups that have differences in the salary. The first test here will show that there are differences between all the four groups in the factor job, and the pairwise will determine pairs by pairs significance of differences. If we scroll down to the again here shows that interaction between job and gender, doctors with whether male or female and their mean. Again, it's repetition of what is in the tables above. The most important one I would like to look at is the plot here. As shown here, when plotting the factor 1, which is the job with the salary earned, you see that the doctor have the highest mean for salary and the nurse are the lowest. For male and females, we can see that the average salary is higher for male compared to females, and in the last one showing that gender and occupation have an effect on salary earned by individual. This is the way to do factorial ANOVA or two-way ANOVA in SPSS. Three-way ANOVA followed by post hoc test in SPSS. Three-way ANOVA is Factorial ANOVA. The test is used when there are three different factors or three different independent variables and one dependent variable. Here in this SPSS data view, I had inserted a data. There are three factors or three independent variables and one dependent variable. The three factors are: the first one, the job factor, which have 4 levels in it: doctor, dentist, pharmacist, and nurses. So there are 4 groups or 4 categories in this factor. The second factor is the qualification factor for PhD. The PhD factor have 2 levels. Either you have a PhD or no PhD. So there are 2 categories. The third factor is the gender factor, and it have 2 levels in it, male or female. So there are 2 groups. The dependent variable, which is the salary, is the wages earned by individual per year in pounds. So this dependent variable is a continuous variable. For this data, we have 3 factors: job, PhD, gender, and one dependent variable, which is the salary. To find out whether there is a difference between the salary earned by doctors, dentists, pharmacists, and nurses, and whether there is a difference in the salary earned based on factor 2, which is having a PhD or no PhD, and to find out whether there is a difference in the salary based on the gender, whether you are a male or a female. Three-way ANOVA statistical test will be performed. The test will examine whether there is a difference among the levels for factor 1, and whether there is a difference among the levels within factor 2, and whether there is a difference in the level among factor 3, which is the gender, based on the salary. The test also will examine whether there is an interaction between different factors that might have an effect on the salary. To perform the three-way ANOVA, 7 hypotheses will be generated. The first null hypothesis states that there is no differences in the means among the levels in factor number 1. The second null hypothesis states that there is no differences in the mean for factor 2 in terms of the salary. The third null hypothesis states that there is no differences in the mean for factor 3, and the fourth null hypothesis states that there is no interaction between factor 1 and factor 2. The fifth null hypothesis states that there is no interaction between factor 1 and factor 3, and the sixth null hypothesis states that there is no interaction between factor 2 and factor 3, and the seventh null hypothesis states that there is no interaction between factor 1 and factor 2 and factor 3, and they have no effect on the salary earned. To do the analysis, click on Analyze, scroll down to General Linear Model, and then click on Univariate. In this window here, move the salary into the dependent variable, and the job and the PhD and the gender into the fixed factors. Click on Plots, move the job into the horizontal axis, click on Add the PhD into a horizontal axis, click on Add, and the gender into a horizontal axis, click on Add. Then select the job, move it to horizontal axis, PhD into separate line, Add, and then job again into horizontal, gender into separate, and then Add, and then PhD into horizontal and gender into separate, then Add, and then select the job finally into the horizontal, PhD into separate, and gender into separate plots. Click on Adds. Now we have plots for all possible combination of interaction. Click on Continue. Click on Post Hoc. Since there are 4 levels in the factor for job, post hoc test will be done for that. There is no point of choosing post hoc test for gender and PhD, as both of them are binomial. They only have 2 categories in them. Click on Tucky here, choose the Tucky post hoc test. Click on Continue. Post hoc test will look for all possible combination and pairwise between 2 groups and determine whether there is a difference in the mean and whether there is a significant difference between these 2 groups within the job factor. Click on estimated marginal means and select all the factors here and all the factors and factor interaction, move them to the display means for, and then click on compare main effect, click on OK, and for the click on the save icon and click on unstandardized, click continue. For the options, select the descriptive statistics, homogeneity of test, and estimate of the size effect. Click on continue and then click on OK. The SPSS will generate several tables and plots toward the end, and for the first table it shows the number of cases included in each factor with its sub-level, as we have here for the job factor 4 levels, and there are 24 participants in each group. PhD 2 levels, and there are 48 participants in each group, and gender 2 groups, male and females, and they have 48 in each group. For the second table, descriptive statistics shows the mean and the standard deviation for the 3 factors combined. As we can see here, job level 1 doctors who have a PhD and who is male, this is their mean salary, and for female this is their mean salary, and for doctor who have no PhD, this is the mean for the male and the female, and for dentist the same, and pharmacist and nurses. The third table is the Levin's test for equality of variances. Again, the table shows that there is no homogeneity of variances, so there is a heterogeneity of variances, and one of the assumptions for performing three-way ANOVA is violated. However, we will continue with the analysis as the ANOVA is a robust method to perform analysis using it. The next table is the test of between subject effect. This is the table will determine the statistical differences for each individual factor, the main factors, which are the 3 factors, job, PhD, and gender, and then the interaction between these factors, all possible interactions. So we are going to ignore the first 2 rows here, corrected model and intercept. For the job factor, there is a significant differences in terms of the salary earned among the 4 different groups: doctors, dentists, pharmacists, and nurses. For the PhD factor, there is again a significant difference in the salary earned for those who have a PhD compared to those who do not have a PhD. However, for the third factor, which is the gender, it shows that there is no differences in the salary or no differences in the mean of the salary earned between those who are males or females. So the gender have no effect on the amount of money earned annually. The interaction between job and PhD indicate that there is a significant differences on the salary earned. However, job and gender have no significant difference, and there is no interaction and there is no effect on the salary earned. PhD and gender, again, there is no significant differences between PhD and gender. For the final interaction, which is job, PhD, and gender, again, there is no significant differences, which indicate that interaction between these 3 factors have no influences on the salary earned. The other tables are just subgroups for the all different factors and interactions. This table shows that the pairwise comparison using Tucky test, since we have 4 levels in that factor, doctor, dentist, pharmacist, and nurses, and the test will combine and test pairwise groups to find whether there is a significant differences between doctor and dentist, or doctor and pharmacist, or doctor and nurses. The analysis here shows that there is a significant difference. If we scroll down toward the end, the first plot shows the job and the salary earned, the mean salary earned. As we can see here, that doctor have the highest salary and nurses the lowest salary. The second plot shows that those who have a PhD tend to have higher salary than those who without a PhD. The other graph shows here factor interaction between factor, jobs, and PhDs, and we can see from this plot that those who have a PhD have a higher salary compared to those who do not have a PhD. Here, whether they are doctor or dentist or pharmacist or nurses. The next plot shows that gender have no influences on the salary earned. And finally, interaction between having a PhD and a job, and whether you are a male or a female. And it shows here that PhD have those who have a PhD have higher salary compared to those who do not have, and similarly the female. So this indicates that gender have no influence on the salary earned. So this is the way to perform three-way ANOVA statistical test analysis in SPSS.